Hi everybody and welcome to today's Lego Technic video. I'm excited to present to you my latest project, something I've called a RoboDog. So the idea of it is that it's a four-legged walking robot. And this project kind of got started when I was playing around with a couple of lift arms like this. I had this arrangement for another project that I was working on, and I kind of noticed that it kind of reminded me of a alligator leg. So the idea was that you sort of had this leg like this, rotate around and kind of make a step. And if I had four of these and they all kind of step forward, then I can get the whole body to move forward like that. Then the legs and then the body, and I thought, oh, this would be great, this could kind of make a walking robot. So that was the inspiration of this project. I've developed it since then, and this is the end result. So if you'd like to see more about it, please keep watching. Alright, so the first problem I had to solve was just around the flexibility of the leg and the strength of the leg. So obviously at the moment, I guess it's the knee joint, lower leg and upper leg. This lower leg is just loose, this concept. At the moment it's got a frictionless pin, and the problem of course with this is that it can't hold any weight. As soon as you put any weight on it, the leg will just kind of slip out like that, or at the back it will slip out in this direction, or that direction. So I needed some sort of solution whereby this lower leg was kind of kept steady relative to the body, so pretty much at 90 degrees to the body, so that it can support weight. And the solution to that was an arrangement like this, whereby we've got this gear here which is steady, and the leg, as that rotates around, will always keep a 90-degree angle to the body. So for example, as I rotate this around like this, you can see that lower leg is always maintaining that vertical direction, and it can't rotate, unlike the other design, around this point here. So that way it can actually support weight and step and rotate like this, and make a step around like that. And the way this works, I've just got a couple of turntables in here. So this is a turntable there and a turntable over here, and I've got this gear here driving the leg. And by having these kind of small gears connecting the two, kind of like planetary gears, we've got this arrangement whereby that leg can step forward. So that is how the leg can rotate and support weight. Okay, so once I created the leg design, it really just came down to putting four of these together into some sort of robot body, and this is what I came up with. I ended up using four medium-sized powered-up motors, so they are under here, 1, 2, 3, 4. They're driven through some bevel gears to drive each of the legs. And I've of course used powered up so that I can program the legs and control them individually through the powered up app, which I'll demonstrate in a minute. So that is pretty much the design of the robot. Now you might be wondering about this part at the top here. I will explain more about that later once I demonstrate some of the walking capability of the robot. Okay, so I'll now demonstrate the robot walking mechanism. So what I've got here on the left is a powered up app whereby I've created four color-coded buttons that control each of the legs. This is just to demonstrate the leg action, and the first problem I had was around which leg to move first. So I'll just demonstrate, for example, if I move, say, the yellow leg at the front here, I run into a problem straight away. So if I move that leg, look at that, it lifts up and moves forward, but the whole robot tips forward. And that is the reason for this part at the top. This is kind of like a balancing mechanism. So the problem with it here is that if we move that front leg forward first, we lose balance. Now, of course, one of the ways around that is to simply, instead of you moving the front leg, is to first move the back leg. So I can first, for example, move the blue leg, and now the balance is okay because there's enough weight at the front to keep the robot in balance. So I can move that leg forward like that. But then once I start moving the green leg at the back, we run into the same problem again. We start tipping backwards because now this leg here is not at the front supporting that weight. So again, got an issue there. So that is the whole reason for this balancing mechanism. I can move this balance forward and backwards. So the idea is that pretty much like, say, a walking duck, it kind of waddles because it has to kind of rebalance itself as it moves each leg. It kind of, once you move one leg forward and you start lifting the other one, you have to put your weight on that left leg in order to move your right leg, and vice versa when you do the right leg. So just going back to the beginning state, What the idea is then is that I move the weight forward. So now the weight is on the front legs. I could then move the back legs around, 1, 2, without losing balance. I can then move the weight to the back, which then allows me to move the front legs like that, and then move the weight back to the middle. And now that all the legs are in the forward state, we can move the entire body forward like that and create one step. So that is the whole stepping sequence, and I've built that stepping sequence into this controller here, which allows me to execute that whole sequence and make one step forward. Alright, so like I said, I've programmed in the forward movements into this joystick here, so when I move that up, the whole forward stepping sequence will begin. So let's watch that. So it starts off with the weight going forwards, the back legs being moved to the front position, the weight going back, then the front legs move forward, and then the whole body will step forward as the final part of the sequence. And then because I'm still holding the joystick up, the whole sequence will repeat. And there goes the robot. It's slow and steady, but it's very cool to watch. I really enjoy watching this robot stepping forwards. And as soon as I let go of the joystick, the sequence will continue and finish until it's back to the starting state. There we go. Good boy. Now of course we also want to be able to walk backwards, so I've also included a backward walking sequence. So by reversing the entire forward sequence, we can make the robot go backwards, just like this. Moves its weight around, then moves each of its front legs into reverse position, moves the weight to keep its balance, and moves the back legs, and then repeats the whole sequence. So that is the robot walking backwards. Alright, so walking backwards and forwards, I've also managed to make the robot being able to rotate, make it left or right turn. So I'll just demonstrate that. So I'll just demonstrate a right turn. The way it does that is just by using its rear leg and kind of pushing itself around. I'll just show you how that works. So we turn the right leg step, and look at that. Each time it pushes itself around, probably about 10 or 15 degrees. So after repeating this sequence maybe 10-15 times, you can do a 180 degree turn. But at the moment I'm just trying to do a 90 degree turn, and then once we've turned, we can start walking forward again. So again, we go back into the forward sequence. And then once we've completed the forward sequence, we can maybe start turning again. And we can very slowly and steadily walk to wherever we need to go. Just make sure you're not in a hurry. And then once the robot is tired and had enough, you can sit down and have a rest. Alright, that was my RoboDog project. Hope you enjoyed this video. Please like and subscribe, and we'll see you next time. Thanks for watching.